Hey everyone, hope you all are doing well. We are going to learn about what are logic gates in this video. But before that, have you ever wondered what's inside the electronic devices you use daily? We have plenty of electronic or digital devices these days. Phones, TV, laptop, gaming devices are part of our daily lives, used for texting, using microphones, gaming, calculating, sensing, listening, converting, speaking, or watching movies. To run all these functions in a device like phone or laptop is a bit difficult. So, what makes these functions run smoothly? The processors, or electronic chips present in these devices. These processors have multiple units in them, each running a specific function. They have control unit, arithmetic and logic unit, memory to store data, registers, and many more. These units also have circuits made with logic gates, electronic components like capacitors, diodes, resistors, and switches. We are going to focus on logic gates for now. If we take a basic flow chart or hierarchy, we have transistors at the lower level. Number of transistors make a logic gate. Many logic gates form an IC, integrated circuit. The ICs are implemented in the circuit along with other electronic components, which then turns into an electronic board placed in your devices. Since logic gates are present in the lower level of the flow, they serve as the basic requirement when manufacturing electronic devices. We can say the logic gates are basic building blocks in digital electronics. You might think the transistors were at lowest level of flow chart. So why do we say logic gates are basic building blocks? Well, for that we need to understand how the analog electronics and digital electronics are related. We can take waveforms and compare them to see the resemblance. If you observe the analog signal, it's in sine waveform. The waveform has two halves. One half above the line is a positive cycle, and other half below the line is a negative cycle. If we assume this waveform is for voltage, the voltage above the line is high voltage or positive voltage, whereas the voltage below the line is low voltage or negative voltage. In sine waveform, the voltage increases gradually, reaching a maximum value, then eventually starts dropping until it reaches the minimum value and starts rising again. But in digital waveform, there is no such thing as increasing and decreasing voltage with respect to time, because the digital wave is in square form. Of course there is a positive half and a negative half in the square wave as well, but there are only two values which indicate the voltage. The high voltage is indicated by 1 and the low voltage is indicated by 0. We can see from the waveform, the voltage is dropping to 0 from 1 directly, and again rising abruptly. This 0 and 1 is what we are going to use primarily in our digital electronics. So, you better remember that the values greater than 0, or the positive values, are considered 1, and the values smaller than 0, or negative values, are considered as 0. In digital electronics, 0 stand for low value, false state, off condition. 1 stand for high value, true state, on condition. 1 and 0 together are called as binary digits, or binary numbers, in digital electronics, whereby of binary stands for 2, 0, and 1. How are these digits going to help us? Imagine a switch. It can have only two states, off state and on state. If the switch is for bulb, we know the bulb won't glow when the switch is off. If we try to represent it through sine waveform, we can say there is no current flow because the switch is off. Voltage across the bulb will be 0. But if we turn on the switch, the current flows and the bulb glows. The voltage rises to certain value as well. In sine wave, there is increment and decrement of values, making it a bit difficult to represent the working of switch. But if we take the square wave, we can easily represent the off state as 0, where the voltage is 0 as well, and on state as 1, with presence of certain voltage across the bulb. We can say, whenever the switch is off, the digital wave shows 0, and whenever the switch is on, the digital wave shows 1. In other words, to make a circuit digital, we need something that works similar as switch, an electronic component that can work with 0 and 1. And that device is nothing but a transistor or MOSFETs. The transistors work as switches. I assume that you are familiar with the concept of transistors and their working. If not, please let me know through comment section, so I can make a video on it. We have two types of transistor, NMOS and PMOS. NMOS transistor turns on when the input is 1, and PMOS transistor turn on when the input is 0. Now, if you remember, we saw in the flow chart that logic gates are made of transistors. A number of transistors together form a block called gate. This is why we say logic gates are basic building blocks. To sum up this video, you need to remember, in digital electronic, we deal with 0 and 1, where 1 represents higher values or on state, and 0 represents lower values or off state. So we take transistors that work as switch to toggle between 1 and 0. The transistors together form a logic gate, making it a basic building block of digital circuits. This is it for today. Thanks for watching, and don't forget to subscribe. See you in the next video.